So next, let's take a look at question 4. And we're given that the rate of change of a function, whatever that function is given by the expression cosine x minus cosecant x cotangent x. So we don't actually have to take a derivative to figure out the rate of change. It's given to us. We don't know yet how to take derivatives of these functions. But what the question wants us to do is to show that the rate of change can also be expressed as negative cosine x cotangent square x. And this is, so for us, to be able to do this is actually helpful to us, because if, for instance, we wanted to understand the critical points of this function, then we would be setting that rate of change equal to 0, and it's easier to understand when the rate, like to solve for the critical points, when we can express our rate of change in this form with two factors, and we understand, the zeros of each of those factors, as opposed to this form where, how do we even start understanding the critical points there? So just a little bit of motivation why we would care about, building tools to do this kind of thing. But in any case, we're not asked about critical points, so let's just try and figure out how to get from this expression down to that expression. So I start by writing down what's given in the question, and then, a standard strategy is to rewrite things in terms of sines and cosines, which is what I do in the next line. And at that point, you will see that we have a cosine common that we can factor out. And once I factored that out, I'm left with 1 minus cosecant times cosecant, right? So because 1 over sine is just cosecant. And then that's 1 minus cosecant square. And at this point, you might remember that cosecant square x minus 1 is cotangent square x. So maybe you remember this, or maybe you don't remember this, but I'll show you what to do if you didn't remember that identity. But for now, hypothetically speaking, if we remember this identity, which follows from the Pythagorean identity, then we will know that this can be replaced by negative cotangent square x, and we would be done, right? We would have gotten down to the expression we were looking for. But let's say you didn't remember this Pythagorean identity, then what could we do? Well, in that case, we would be from this step, let's do this. So from this step right here, we might go down to here, where instead of writing it as 1 minus cosecant square, we write it as 1 minus sine square. And then what I'm going to do is do some arithmetic with these fractions, take a common denominator, and now I have sine square minus 1 up top. And remember, from the Pythagorean identity, we know that sine square x plus cosine square x equals 1. And this tells me that, so if I wanted sine square x minus 1, that's going to be negative cosine square x. So I can replace that numerator by negative cosine square x, and then it gives me, because all of this is just negative cotangent square x. So that's how we get down to the expression we are looking for. So a couple of different ways to do it. Maybe you remember this version of the Pythagorean identity, but if not, you can still make progress with this problem.